So Ashley, you're here to talk about whose cert is it anyway? So that's cool. We're gonna duck out and leave you. We can add your slides to the stream. There you go.
Brilliant.
And off you go. We'll jump in if there's any questions as you go along, okay?
Fantastic. Yeah, I should be able to accommodate questions. I'll certainly, hopefully, have time at the end. Thank you very much. So yeah, hi everyone. It's really great to be here. This is actually my first proper big external talk. I've done some internal stuff before. So yeah, I'm really excited to do this and to talk about cert-manager and everything relating to it. So I'm a senior software engineer at JetStack, who you might have seen in the little sponsors list down below. And I'm also a cert-manager maintainer, which is really good because I'm going to talk about cert-manager a lot. I've passed the first hurdle. I've got a reminder in my notes to start my timer, which I've done. So we've got off to a good start here. I'm going to be talking about TLS Trust, which is a topic that I don't think gets enough attention at all. I don't think we talk about it enough. So I'm going to talk about it and hopefully give it more attention. And I think it's critically important for security on today's internet, and it's such a big deal. Further to that, it wouldn't help much if I just talked about it. So I'm going to talk about how I think the cert-manager project can help. So you don't need to be familiar with cert-manager or TLS to get anything out of this talk. I'm going to talk about the basics of both of them. If you've not heard of cert-manager, it's sort of a tool for getting TLS certificates for your Kubernetes clusters. It's sort of a Kubernetes native thing for that. It's got tons of stars on GitHub. That's always a good indicator. There's a lot of people who've contributed to it. It's fully open source. We're always looking for more contributors if you're wanting to get involved. It's actually now CNCF incubating. It's a part of CNCF and has just reached the incubating stage. That's still pretty on the down low. There's a bigger announcement coming later. But yeah, it's really great. We're really happy to reach that stage. It's fantastic progress for us. And yeah, tons of plugins. I wrote that because there's just so much there, right? However you want to get your certificates issued, whether that's Venafi, whether that's HashiCorp Vault, whether that's Acme and TLS, Acme and Let's Encrypt, sorry, it's probably there already in cert-manager. If you're using Let's Encrypt or Acme specifically, there's tons of ways to do your challenges. You don't need to know what those are, but there's tons of ways to do them. And if there isn't already a thing which does your certificate thing, you can write one, right? It's all open source. It all works quite nicely. So I don't want to leave anyone behind here, and I'm going to go over just the very basics of what TLS is and what it does, just because I'm going to spend the rest of this talking about it, and I don't want anyone to be wondering what I'm talking about. So it is the encryption for today's internet, essentially. The vast majority of websites, APIs, whatever, is using TLS. I'm using it to give this talk. My connection to the server is encrypted with TLS. It provides several things. It stops people tampering with your data. It stops people seeing what you're saying to the server you're communicating with. And it allows you to be sure that who you're talking to is who you think you're talking to. So if you connect to cert-manager.io, you can be pretty sure that you're getting our website and not just some random thing. For the avoidance of doubt, if you want to put it simply, that little padlock in your browser when you're connecting to something, which you can probably see now, that's TLS, right? And it's the encryption. It's the bit that stops the browser saying it's not secure. That's TLS. Again, we'll go very brief on this. We're not going to go really into the details of a TLS handshake, but we'll look at one in general terms. A TLS handshake is sort of a TLS connection. It's how we start a TLS connection. So imagine a client, which could be a laptop, a phone, a server, whatever. It's reaching out and saying, hey, I want to connect to cert-manager.io, say if you typed it into your browser. So after some DNS lookups and everything, it initiates a TLS handshake and says, I want cert-manager.io. The server receives that request and it says, yeah, I know what cert-manager.io is. So here's the certificate chain that proves that I own it and am authorized to serve it. That's, that's simplified, but that's kind of the general gist of what this all entails. And for the avoidance of doubt, cert-manager helps you to get that certificate chain in your Kubernetes cluster. That's what it does. It's again, we're simplifying, but that's what it does. So if you've used Kubernetes at all, you're probably familiar with the idea of writing YAML to specify resources, right? This is sort of what cert-manager does. It adds custom resources for certificates. So you can write some YAML to say, hey, I want a certificate that looks like this. I want these domain names in it. And cert-manager will go off and fetch your YAML, and in the background will sort out whatever you need to get that certificate. This is simplified slightly, right? The issuer stuff at the bottom specifically needs a little bit more setup, but it's not that complicated, and it really is pretty basic to get the certificates that you need. You can do a lot more complicated stuff if you want to, but it doesn't need to be complicated. And actually, this pretty much just works. Before I go any further onto this, I'd just like to be clear that we're talking about a client talking to a server here, like the example that I gave of connecting to cert-manager.io. But that's not how TLS has to work, right? After the client has sent its request, the server can go, hey, actually, I need you to send me a certificate as well and prove who you are. That's called MTLS often, or mutual TLS. That exists, it's a thing. Not really with websites on the internet, but it does exist for a lot of APIs and stuff. We're not going to talk about that just because we don't need to, right? It's the same thing as what we're talking about, just in reverse. Like it's the server asking something from the client rather than the client asking something from the server. The ideas are very similar in both cases, so anything we learn here can be applied in both cases. It all works out fine. So the key thing really that I'm trying to get across here is that getting a certificate is actually only half the problem we have to solve. You can use cert-manager to get your certificate. You can use whatever you like to get your certificate. You don't have to use cert-manager. But once you've got it, you've not solved everything, right? That doesn't complete TLS on its own. Without solving the other half of the problem, you actually can't use that certificate securely, or your client can't. So what is the rest of the problem? I hear you ask, right? I pretend to hear you ask. And the other part is trust. And you don't get any points for guessing that because it was in the title of the talk and in the description of the talk, and I mentioned it earlier, but it's trust, right? That's the problem that we need to solve. Specifically, if I reach out to cert-manager.io or example.com or any API or whatever, and they send me back a certificate, how do I know I can trust that certificate? How do I know that it's legitimate or valid for what I want? I should warn you now, I'm going to say the word trust a lot. Like it's gone past the point for me where it no longer like means anything. You know, when you hear a word so much, it starts to lose its meaning. So just, you're going to have to walk that mile with me, I'm afraid. That's just the way of things. So to dig into trust, we need to dig into what a certificate chain is. You might have noticed I was careful to say that in the example previously and not just say a certificate. So a website certificate is usually part of a chain, right? In fact, if you've got a server that's using TLS and it's only serving one certificate, it's probably misconfigured. It's not definitely, but there's a good chance that it's misconfigured and that you could have problems down the road. Usually, your website will serve at least 2, maybe 3 certificates, and the other certificates that it serves identify issuers. So they're certificates which issue other certificates. And that's what forms the chain, because these things are linked in a cryptographic sense. Usually the chain will start with what we call a leaf certificate. So that's the thing that identifies the website or the API or however you're using TLS. So in our example earlier, it was cert-manager.io. The one that said cert-manager.io, that's the leaf certificate. Usually the chain will end in a root certificate. And that the definition of a root certificate, if you like, is that it's self-signed. So we can't find a certificate which issued a root certificate because it issued itself. That seems a bit confusing, but you don't really need to worry about the detail of that. And we say, as a matter of terminology, we say that certificate B is issued by certificate A if B is signed by A's private key. Again, we don't need to go into the cryptography of that. We just need to know that it works. And it does work. That's what, as I say, I'm using to give this talk. It works in today's internet, and it will continue to work as far as we know until we can build a big enough quantum computer. But we're not going to go down that rabbit hole. Things are in motion with that, but we've definitely not got time for that today. So the way that trust works further to that is that the client must explicitly trust one of the certs in the chain. And usually that explicit trust, will be a root certificate. And in fact, that's the only way that a root certificate can be trusted, because as I said, we can't find an issuer which issued a root certificate because it issues itself. It's a loop. There are other TLS checks that we do, right? It's not as simple as just walking up this chain. and verifying everything in it, like we need to check that the issuing certificates are actually allowed to do that. And there's little bits that we can set to identify that, but they're not important to us right now. Those checks are we just believe that they're done. We're just talking about looking at the chains. And a crucial thing to take away is that clients actually have to know what they trust before they attempt to connect. And the details of why they need to do that are somewhat complicated and not important, but it is important that they do know before they make a connection. They can't decide what they trust in the middle of doing a TLS handshake. That doesn't actually work out securely, and they need to know before they connect. This can be quite confusing, so we'll look at a concrete example of this. While I was writing these slides a couple of weeks ago, I actually retrieved the certificate for cert-manager.io on my laptop. I used OpenSSL, but you can do it in your browser or whatever. So let's look at what happened when I did that, right? So cert-manager.io uses Let's Encrypt to get its certificate, or at least it did 2 weeks ago, and I think it still does today. The Leaf certificate is exactly what we expect it to be, right? It's cert-manager.io. That's the website we're trying to connect to. That's great, but we've never seen that certificate before. We've never seen that specific set of bytes which identify that certificate. Actually, we look at the chain that it sends, and we have 3 certificates in it, right? There's the Leaf certificate, but then that's issued by what we call an intermediate certificate called R3. That's the sort of workhorse certificate that Let's Encrypt use to issue other certificates. They'll have that on a server somewhere, and that's what they use to actually sign requests that they get. In turn, we see that R3 is issued by ISRG root X1, which is incredibly difficult to say, especially when you're a little nervous. So I'm going to try not to say that too much, but we see that ISRG root X1 is self-signed, so it's a root certificate. So that must be the end of the chain, right? We can't find another certificate which issued that one. So as it happens, my laptop already knew about ISRG root X1, right? It was already on my laptop, on my disk, before I reached out to the website to try and connect to it. It was just there already. And my TLS client, in this case OpenSSL, but the same with browsers and everything, it looks for that certificate in what we call a trust store, which is a gigantic list of certificates in this case. So the question we ask is this certificate in the trust store? And if it is, then we're done, right? We've formed a chain from the leaf to the root. And actually, the trust store is the ultimate decider of this. If we can find something in the chain that we trust, it's all good, and we can use it to complete the chain. And we decide whether we trust it based on whether or not it's in that trust store. The obvious follow-up question is, why do I trust that already? Why was it on my laptop? And the sort of on the face of it, the answer is because it's in this file, which I've put on the slide here, which is my trust store. That's where all the certificates live. I'm using Debian to give this talk, and it just so happens that Debian has the trust store at that location. And actually, that comes from a Debian package, which is called CA certificates. So it comes from my operating system vendor, in this case Debian, a type of Linux. So the package is built on actually what is published by Mozilla, who create Firefox, which is a great browser, and that's what I normally use. As it happens, most Linux distributions actually get their trust stores from Mozilla, because Mozilla are very careful at sort of vetting who's allowed to have their certificates in the trust store. And we all use that work daily, right? Like most Linux distributions, and therefore most container base images, actually use this base image from Mozilla. So we see sort of another chain of trust here. We had the cryptographic certificate chain before, where we had the Leaf certificate, and then we had R3, and then ISRG root X1. But actually here we've got a different type of chain of trust. This is kind of more human, right? I trust Debian because I'm running it on my laptop. Debian trusts Mozilla because they're good at what they do. And Mozilla trust Let's Encrypt, so they trust ISRG root X1, so it appears on my laptop, right? And that's all well and good. That's fantastic. So what's the problem, right? What's the problem with any of this? I've just given an example of how it all works. Where can it... It's not that simple, obviously, or this talk would be a lot shorter. So the actual problem that we have to look into is, well, what happens if a trust store fails, right? What happens if this goes wrong? It's fair to say that a trust store compromise would be bad news. I can think of vulnerabilities which are worse than that, but in terms of sort of trust and connecting to things on the modern internet, there's not much worse. It kind of breaks everything. One possible failure is that something evil could be added to a trust store, right? Like someone's hacked your laptop and they've added something evil, and now they can sign certificates arbitrarily and intercept connections that you might make from your laptop. A much worse outcome, actually, is that one of the certs that's already in that trust store might be compromised. I'm not saying that that's likely, right? Let's Encrypt, who have that ISRG root X1. Hopefully that's the last time I say that. Let's Encrypt, who have that certificate, are very competent people. They run a tight ship. Like, they do everything by the book. And I don't think they're likely to lose control of their private keys and therefore the certificate that is in the trust store. But it could happen. There's a lot of certificates in a trust store. And I think it's just good engineering to be prepared for the possibility of something like this going wrong. I think it behooves us to do that. So what does it actually mean if we end up having a compromised cert? Well, it means nothing good, right? Attackers can then read any data that the client is sending to the server, or indeed that the server is sending to the client, if they can intercept network traffic. That includes passwords and bank details, but the one that often makes people really sweat is medical data, right? That tends to be a touchy subject. They can also impersonate your server. So if you're serving downloads to your clients, for example, they can hack those downloads, add Trojans, they do all kinds of horrible things like corporate espionage. Nothing good happens here, right? Some people will look at sort of code signing as a solution to this. We have code signing for the cert-manager containers that people install and run in their Kubernetes clusters. But that wouldn't save you in this case, because actually usually you're downloading the public key from a website using TLS. So if you can't trust TLS, you can't trust that you got the actual public key that you need to verify these packages that you're trying to install or download or whatever. That's obviously bad, right? Like there's nothing good there. In fact, often these public keys will come with an OS when you install it, and you've already got it on your laptop then, but you can't trust the OS image that you download if you don't trust TLS, right? Another option is checksums. You can check checksums, which is very repetitious. But the same thing applies, right? If you can't trust the thing you're downloading the package from, you can't trust the checksum that it gives you either, because the attacker can just replace that. That's why TLS breaks are so scary. There's a good question in the chat, which is the trust store different for every different device? And actually, it can be, but specifically in Linux and therefore in Kubernetes, most of the time, it tends to come from the same Mozilla trust store. But especially if you're modifying it or doing anything with it, it does vary. Certainly, if you've got a phone or any laptop, the OS vendor is usually the thing that you're getting it from, but it can vary. So what I'm saying here really is that we need the ability to update our trust stores, and we need to be able to do that quickly, right? If something goes wrong, we need to be able to fix the problem. So how does that work? Well, I talked about with my laptop, it's running Debian, so I just run apt. That's the update manager I'm using, and it updates the certificates and everything's great. That's fine. My phone gets OS updates regularly. Your Windows laptop, your Mac OS laptop, your server running whatever it's running, you just update it. You keep it up to date. That's good sort of security hygiene, right? But the situation's actually a little bit more complicated when you consider Kubernetes, because trust stores actually most commonly are baked into your containers, right? You build your container from some base image usually. That might be distroless. It could be Python, Alpine, Debian, Ubuntu, whatever. But usually you're getting the trust store from that base image. And so to update it, we actually need to rebuild the container with a new base image. So a new base image needs to be released first, and then we need to rebuild off that. If you look at this example Kubernetes cluster that I've drawn here, we're running 6 pods with different OSs in them, different distributions. And I've added in a question mark to represent the unknown as well, right? But actually, these pods could be running multiple containers each. Each container could have its own trust store. And most organizations probably aren't just running one cluster. And even if they are running one cluster, they're probably not just running 6 pods. So this problem actually scales out quite a lot. There's quite a lot of trust stores in any given Kubernetes cluster, and even more in any organization. This is ignoring like nodes, which outside of running applications inside Kubernetes, your nodes will have a trust store. You can pay cloud vendors to sort that out for you. A lot of people are doing that, I'm sure. But inside the cluster, there's actually quite a lot that you need to do to update your trust stores. So, as I said, updating your trust store will require rebuilding every container in every pod in every cluster that you run. And what if one of the distros is slow or they're end of life and it won't ever update, or something else has gone wrong? Any of these are a disaster if we need to do this in a hurry, right? If there's been a compromise of a trusted certificate, that would be front page news, right? You'd see it on every news site on the world, and it'd be tremendously stressful and high pressure. And the status quo today in Kubernetes is that while this is all happening and everything's going wrong, you need to rebuild the entire world, right? You need to rebuild every container in a high pressure scenario. So the time for disaster recovery is actually quite high. That said, I don't want to be like all doom and gloom about this, right? It doesn't have to be that there's a compromise. Sometimes we want to change trust bundles completely normally. So a lot of organizations will run their own issuing CAs. That's fairly common. That might identify people or machines or be used in test environments or whatever. You commonly see this with service meshes like Istio and Linkerd, like people running their own CAs for that, because you want them local for fast issuance and for other reasons for control as well. So we might want to trust that private CA. And so we have the same problem in how do we get that out to all of our pods and containers, right? There is a little bit of doom and gloom, because if you are running a private CA, that's probably not your primary business concern, right? Most companies are selling something or building something, or whatever organization you're running, you're probably not in the business of running private CAs. So they're probably more likely to be compromised than publicly trusted certs like the ones we've discussed already. So this actually, if you're doing private CAs, there's even more incentive to be able to fix that problem quickly by rolling out updates. So I think a solution to this actually ties back to Kubernetes, right? We've seen before with this example of a cert-manager certificate that a Kubernetes resource will specify a state that we want to exist, right? That's why we write the YAML. Controllers will then go and take that state and try and make reality match it. Right? That's how Kubernetes works. You write pod YAML, and the pod controller will try and make pods match that YAML. So you can kind of see how we might have a custom resource which does the same thing for trust bundles, right? You can imagine that this is possible. And actually, you might have guessed where this is going based on me talking about this. Introducing Trust Manager, right? If I had a little party popper or something, I would do it right now, but you'll just have to enjoy the emoji in the absence of that. I genuinely cannot think of a better sort of elevator pitch for Trust Manager than to say it's like cert-manager, but it's for trust, right? It does what cert-manager does, but with trust stores instead of certificates. So you write a bundle resource in YAML or whatever. You list what you want in that bundle. That might be a publicly trusted bundle like the Mozilla one that you're already using, most likely. It could come from a config map or a secret or whatever. And then we can then write that into some target, which currently we actually define as being a config map, because that works for this use case. So let's look at an example of what that might look like, right? Say that we want to include the Mozilla Trust Store, the one that we're all using pretty much, and some private CA for some organization, right? It doesn't really matter what it is. If we want that to appear in every namespace, what does that look like? And it looks like this. So with the certificate example that I gave previously, that was simplified, right? I didn't show you all of the steps. This is all of the steps. It's no more complicated than this. I do have to add the caveat to this that the public stuff isn't actually implemented yet in the actual project Trust Manager. We've been discussing how best we can do that, but the idea is the same, and it will end up looking very much like this. So you list the sources that you want, and then this bundle would write a config map called my first bundle to every namespace, which would include the trust bundle that we wanted. And that's all great. So why do we want this, right? Well, first of all, it's easier to do private CAs. Like I mentioned before, you might want to have a private CA to save money or avoid rate limiting, or because you want one locally for your service mesh. This makes that easier, right? You can distribute your trust store across your entire cluster, across every namespace, across multiple clusters if you need. Much easier because it's all specified in one place, and that's the only place you need to update it, right? Private CAs aren't trivial to run. They need some ceremony to do, and like there's work that's required for them, but it's still a super powerful tool to have if you need it. The bigger one, I suppose, is disaster recovery, right? I mentioned the time to recovery for clusters today, like your cluster today probably would require you to rebuild every single container in every pod everywhere, right? You still have to redeploy everything with Trust Manager. You have to change your bundle and then redeploy everything, but you don't have to rebuild everything. And that's actually a huge win because you don't have to, like, rebuilding is going to take a lot longer than redeploying, right? Hopefully. Like your redeploying should be able to be done quite quickly, or ideally would. So the time to disaster recovery is actually massively reduced with this. And you want that time to disaster recovery to be low because, like I said before, if one of these compromises happens, it's going to be a big story and people will get paged in the middle of the night to go and fix things because it will be terrifying. And so you do want to be able to recover quickly. A third thing, which is actually a really cool benefit of this, is that this enables more visibility into what your trust situation looks like. I don't think there's many people who can actually reliably say what trust they have in every container, in every pod, right? Most likely, they're just using a Linux distribution, and that's going to have the Mozilla Trust Store in it. Maybe they're tweaking it and they're adding something else in there, but like, it's pretty difficult to assert what those files contain everywhere. In this case, using Trust Manager, you are specifying exactly what search you want to appear in one place, potentially. So you only need to look at that and then check that everything is using that to be able to assert what is being used in your cluster and what your trust situation looks like. Like to be able to answer the question, is there something dodgy in my trust store? The places you need to look goes down because you've only got all of this specified in one place, ideally. And actually that leads into a very powerful thing, which is the ability to add policy to this. So you can say, not only here's a trust store which contains the things we need to trust, but you can actually go further than that. And you can say, everything must use this. You're not only providing it, but you're forcing things to use it. I think that would be an ideal situation for a lot of clusters because there probably isn't much reason for this to vary for the standard Kubernetes cluster today, I wouldn't think. And actually, we're not the only ones that think this in the cert-manager project, right? Like Kubernetes actually have been looking at this as well. There's an official Kubernetes enhancement proposal for exactly this. They call it a trust anchor set, same as a trust bundle. It's the same thing. And that is in progress and will take a while to do because they're trying to solve the problem upstream in upstream Kubernetes, right? I think Trust Manager being sort of usable today is a huge advantage for sort of setting the tone for this and finding out like what works and what doesn't, and like seeing what problems this solves for people. But also we can just be more ambitious with changes, right? We're not going to break things back. We're not going to break backwards compatibility just because we can, but we can like change things easier. If we want to add an optional third-party dependency, that's totally possible for us to do. So I didn't go with a live demo for this because you can just imagine a config map appearing in every namespace, and that's the demo, right? The YAML that I gave earlier is pretty instructive, I think. But just a heads up that QR codes are incoming if you wanted to scan anything. So first, I'd like to shout out to the Venafi Machine Identity Management Summit, which is happening next week. I should say that Venafi own JetStack, so they are my employer, but it's a free event. And the last sort of similar thing they ran was really cool. Really enjoyed it. It's free, so it might be worth a look, worth a go. They talk about zero trust there, which isn't the best name because it's actually, trust is critical to that. You're not getting rid of trust. You're not trusting the other party by default is all it's saying. And also, like, you may want to learn more about Trust Manager, right? There's a link here to the actual documentation that we have. This is a great first stop if you want to read more about it, you want to play with it maybe and install it. Like I said, the public trust bundle stuff isn't necessarily there yet, but the ideas are there, and we're super keen to get feedback on this, and even more keen potentially to get people involved. If you want to get involved in open source, like this is a good opportunity to get stuck in. And we've had a lot of people make their first contributions to open source to the cert-manager project, and it'd be great for Trust Manager to be an in for people like that as well. So I don't really have much more. So I'd like to just finish by saying, please don't let this keep you up at night. It sounds scary, but it's not like it's not likely that any of these big compromises will happen. I just think it's important that we prepare for it. If you'd like to reach out on any of the channels, like here's some links, please do reach out. It's been great talking, and I hope everyone enjoys the rest of the conference.
Yeah, Ashley, thank you, first of all, amazing. And where are you joining this from? Are you actually across the pond, or did that accent follow you somewhere else?
Yeah, I'm in sort of a fairly rural location just north of Manchester in the UK.
Okay. See, this is a truly international conference. I love it. And it looks like a lot of the folks that are joining us are mostly joining us from other parts of the world, which is fantastic. And this is great. And I think you got to all the questions. There was one sort of, did we answer your question, Rodrigo?
I don't think I did. What I would say is, if you've got any questions about cert-manager itself, on cert-manager.io, which I've said many times, the name of that website many times, we have links to our Slack channels and things like that. So you can totally reach out to us on there. Like all the maintainers hang out on cert-manager on Kubernetes Slack. So if you've got questions, that's a great place to get answers on like the running of it and that kind of thing.
Yeah. Oh, one last question coming in. Is the trust store mostly mounted the trusted?
That is kind of what it looks like in a lot of cases. The actual file that you write it to varies based on the Linux distribution that you're using, and it will also vary based on the operating system you're using. Like Windows and Mac OS will have different solutions for this. So you can't necessarily just look in the file name that I linked earlier, but it's something like that for most things. Like they'll usually on Linux, there'll be a file, and that's what you look at. So mounting a trust store would be putting a file in one of those locations.
Okay, awesome. So we're going to move to the next presenter, but if you can hang out on the chat, if there's any other questions for Ashley, if you've got just a couple more minutes, and also you can post those links in the chat so people can easily get to them, including your links that, you on Twitter or LinkedIn or whatever you want to put in there. But thank you so much. That was super interesting. cert-managers, I mean, you got shout outs for your book. You got shout outs for the project.
I actually haven't written a book, so I'm not sure where that came from, but I'm glad you enjoyed someone's book.
Hey, big credit.
It's been great to be here, so thank you very much.
All righty. Thanks, Ashley.